Some people will claim that globe races and circumnavigations around Antarctica are proof that we live on a globe. However, I am going to point out today that these circumnavigations are not what we're generally told. I'm also going to explain the many different tricks that they use to fool us into believing that Antarctica is a small icy continent at the bottom of a globe, as well as the many major mathematical impossibilities of the overall mileage and time discrepancies. A few of the ways that they manipulate these globe races and circumnavigations is through magnetic declination, GPS safety boundary waypoints, boat speeds, misreporting globe race leg distances, and GPS built-in meridian distance corrections. From this comprehensive guide on globe races and circumnavigations, you will understand how these circumnavigations are manipulated within a pre-coordinated GPS infrastructure to continue to perpetuate the globe lie. First, we're going to start with the Vendee Globe Race. This race happens every 4 years and it starts out in France. This race navigates down through the Cape of Good Hope in Africa, then over to the Cape of Llewellyn in Australia, then over to Cape Horn of South America, and then finally back up to France to finish the race. Now, during this race, the participants follow a set of pre-coordinated GPS waypoints. That GPS waypoints generally guide them along their route during this race. Now we can also follow this race on a tracker. This tracker shows all the different race participants as they navigate this race in real time, and we can follow their route as they navigate around the world and sail back up to France and finish the race. Now, we're going to go back for a second here to the GPS waypoints. These GPS waypoints they follow are called safety boundary waypoints. They are generally placed and located between the 40-degree and 55-degree latitude lines. They follow these safety boundary waypoints not just to guide them along the race, but it also keeps them from going down to the more dangerous turbulent waters below this 60th latitude line. They also prevent any of the sailors from ever actually seeing Antarctica and its vast coastline. Now these GPS safety boundary waypoints also have built-in meridian distance corrections to correct for the longer distances below the equator. And I will get more into those details later. For now, let's have around the world circumnavigation retired sailboat captain Hervé Raboni explain how they use these GPS safety boundary waypoints on these globe races. He will also explain how they manipulate these races through magnetic declination, boat speeds, and manipulating distances on GPS and Google Maps.
Of course, Hervé has figured out that the Earth is flat, and that makes him a friend. But what makes Hervé especially interesting is the fact that Hervé has actually sailed around the world. Not around a phony globe, but around our flat and stationary plane. Hervé was a participant in the 1993 through 94 Whitbread Round the World Race. It is also called the Volvo Ocean Race. Here is Hervé listed as one of the participants. You can look it up for yourself. This is the boat he was on. It was called the Merit Cup. And here are some pictures of Hervé. This is a map of the race route, which began and ended at Southampton in southeast England. Based on his experience and his research, Hervé has some fascinating ideas as to how they have faked the globe, and some important information on what a true flat Earth map should look like. I hope that his information will lead to more investigation.
Now, as the map that Bob has up right now shows you were talking to me earlier about those little lines that are along the route, that those were requirements that you could not go below that. Is that correct?
Yeah, this is interesting, but it's not easy to explain. But it's the Vendee Globe. So maybe you know the Vendee Globe is there is no stop. The opposite of the Whitbread race. There is no stop there. You start in France, and you go around the world, and the organization of the Vendee Globe put this mark here. It's not. It's a GPS point. There is nothing on the sea, but now with the instrument, you know exactly where is the boat on the map. Whatever is the flat earth of the globe, but you know where is the boat. So the boat cannot have to pass between. You see, there is two small points, okay, and the boats of the Vendee Globe have to pass between those 2 points. You see the 2 points here? Yeah, exactly.
Yep, on every single one. Yeah, so that's the boundary.
Okay, but that's very bizarre to do that, because it's for safety. It's to keep the boat away from the Antarctic because the ice it's dangerous, you know. So the organizations do that. Like that, the boats stay away to the Antarctic. But it's strange because they can put only one mark and ask the boat to stay to keep the mark on starboard, on the right, okay, and like that they can go also more on the north if they want, but with these 2 points they are obliged to pass through these 2 points. So the boats have less option, and there is less security too, because if you are in the north of this point and there is a big storm in your south, you're obliged to go to the storm and to pass between those 2 points. You understand me?
Yeah, that's crazy. So, and let me ask you something. Physically, I mean, how do you know you're within the boundaries of those 2 points? Because I mean, looking at them, they look like they're spaced really, really far apart. So, is there some physical marker, or is this like a GPS marker, or how is that done?
It's only GPS, but
Okay.
as I said, with the GPS now, you know exactly where is the boat, so the organization can know where are the boat, and if they really pass between the 2 points. Okay. So that's bizarre, because it's less option for the boat, and it's less security for the boat. If they put only one mark and they ask the boats to stay in the north of, they have to pass in the north of this point, of this mark. It's really better for the course. You have also more options for the strategy, to the option for the forecast, meteorology, where is the wind, etc. But with these 2 points, all the boats have to go through these points, and it's not logic on a race boat. And I sent an email to the organization of the Vendee Globe to ask them that it's not logic to do that, and they never answer me, because now maybe I think it's maybe because if a boat with the instrument that they are very specific now, if a boat is more in the north and another more in the south, and they can know now which kind of wind do you have, because there is very precise forecast map. So if you know exactly in the boat in the north of you have the same wind than you, and he goes faster than you. I mean, he gain more. I can say that. Yeah, he's getting faster to the arrival if it's in the north than if you are in the south, because on the flat earth it's the opposite than on the globe. You're going less distance if you are on the north than on the south. You understand me?
Absolutely. So you're saying in between the specific longitude lines, there's actually a greater distance that you're sailing when you're in the southern hemisphere than you are when you're in the northern hemisphere.
Yeah. Yeah.
Okay, that makes sense. And
So they
obviously,
did stretch them out. They didn't. Okay, that's interesting for the GPS the way they did them there. I mean, and as opposed to skip over, that's interesting.
Today, he makes a claim that magnetic declination is subterfuge to hide the flat Earth, and that magnetic declination doesn't actually exist. His information is very important for our purpose of actually mapping the flat Earth. Anyways, I hope you enjoy Airbay's presentation as much as I did. If Airbay wants to share any follow-up presentations, I will be happy to share them with everyone. Thank you.
Just to explain that they can change the shape and the position of the continent.
Can you click on that magnetic declination map, the world map?
Yeah.
Once it's to the left of that.
Well, let this one just for a second. That's the North Pole, okay? And you see the magnetic declination in the North Pole is very conveniently perfect quarter, okay? With the magnetic declination are also very symmetric, and for me, it's very convenient to inflate the North Pole. You understand what I mean? And we need to pass from the flat Earth to the ball Earth to inflate the North Pole. So I think it's on purpose that the magnetic declination is like that at this position. So now you can maybe put the other magnetic declination. Ben, you want to say something?
Yeah, the one just to the left of that one.
Yeah.
Oh, the one to the left. Okay.
So you were talking about the trip from Brazil to South Africa, correct?
Yeah, to Cape Town. So in the tip, so you see the different shape. So if you start to Recife to Brazil here, if you add the west magnetic declination, it's maybe Recife to South Africa, it's 135, and you have to add 20 to even almost 30 degrees here. Okay, so the boat, if there is no magnetic declination and you adding instead of 135, you're adding 155 or 160, it could be that the real shape of the Africa is the other one that you know on the Air Force One, the other.
This one.
Yeah, you understand? If there is no magnetic declination and you follow the instruction, but you have to go instead of 135, you have to go 155, 160. But you're gonna arrive in Cape Town, in South Africa, because the Africa is the real good shape of Africa is like that.
Right. Okay.
Yeah. So just to explain that with the magnetic declination, they can also change the shape and the position of the Earth. Of the continent.
Yeah, absolutely. Because I mean, there are some areas, especially down in Antarctica, where you have declinations of 170 degrees.
Yeah.
Which means it's like just turn around.
Yeah.
And of course, the reason for that is because there is no magnetic South Pole. It's not down there. Compasses don't work in Antarctica, and so you have to follow the North Pole only, which is towards the center of the flat Earth map. Somewhere in that region anyway. And you would think that, okay, well, no problem, because if it's truly two poles or dipole system and you're down in Antarctica, then the magnetic pole on your compass would be attracted towards the south magnetic pole, near Antarctica. But the problem is there isn't one.
Yeah.
Which, in and of itself completely debunks the entire globe model, among 1,000 other things,
Next, we're going to talk about the Golden Globe Race. This race is very much like the Vendee Globe Race, as it also happens every 4 years, and this race also navigates almost the exact same identical route that the Vendee Globe Race does. You can see it's starting in France and going around the 3 main capes and then back up to France. However, this race takes much longer to complete, as the Golden Globe Race takes about 260 days to complete. So, you can see that there's quite a big difference in the time duration of these races, as the Vendee race only takes about 90 days to complete. So this Golden Globe Race takes almost 3 times longer to finish. The other main difference with this race is that it follows a different set of rules. The rules for this race follow the tradition of the 1968 Golden Globe Race that was won by Sir Robin Knox Johnson. So their ethos is not using any modern-day technology on the boat during the entire race, which includes GPS. They also have to use pre-1988 sailing yachts, which move at a much slower speed than the racing yachts used in the Vendee. So now, we're going to take a look at the math for both of these races and compare. We can first look at the Vendee Globe Race. We can see that it's 90 days with about 25,000 miles. It's navigated with the IMOCA 60 yacht with an average cruising speed of 15 knots or 17 miles per hour. They also have a top speed of 35 knots per hour, which is an incredible sailing speed of 40 miles per hour. But for now, we're just going to go off the average cruising speed to get a base overall distance to reference to with the much greater mileage disparity of the Golden Globe Race. Also, I will note that this average cruising speed is not reflecting the added for miles per hour boost and friction-free sailing of the Antarctica circumpolar current, which I will explain on more detail later. This average cruising speed of 17 miles per hour is only calculated with 14 to 20 miles per hour dependent winds, which are always consistent below the equator with the roaring 40s and the furious 50s winds. So for now, let's take the 17 miles per hour times 24 hours in a day, and we get about 414 miles per day. And then if we take this 414 miles per day average and times that by 90 days, we will have 37,281 miles. Now, this distance is quite a bit further than the official 25,000 mile distances that is listed. This distance is also only on the 40 to 50 degree latitude lines. Now, if we add in an extra 4 miles per hour and from the Antarctica currents, they would be traveling roughly 510 miles a day, and this would come out to about 45,900 miles. And again, this is not all the way out to the 60th parallel or anywhere near Antarctica, so this distance would be much greater. If you extended it out another 10 to 15 degrees latitude to the perimeter of the Antarctica coastline, so we can already see that the estimated overall distance navigated is not even close to the official narrative of these globe races, but the mileage disparities only get much worse. Now let's take a look at the math for the Golden Globe Race. The Rustler 36 yacht, which is the most common yacht used on this race, has an average cruising speed of 6 knots or 7 miles per hour with a top speed of 7 knots, so not much more than the cruising speed. But again, this is a pre-1988 sailing yacht, so it's not a high-end foiling racing yacht. If we do the math with the 7 miles per hour in a day, it comes out to 168 miles per day, and we multiply the 168 miles per day times 260 days, it comes out to a total of 43,680 miles. Now again, this is just between 40 and 50 degrees south latitude. Now, if we figure this with the adjusted Antarctica circumpolar current speeds and add another 4 miles per hour with 11 miles per hour, we would get 264 miles, and the 264 miles per day times 260 days would be about 68,640 miles. and this still not including if this race was extended further out to between 60 to 70 degrees southern latitudes, which again, this is just a hypothetical to give a better idea of what distance could be navigated around the coastline of Antarctica, as there is too much ice to navigate around the 60-degree latitude. But even with what we already calculated with the 43,680 miles at just the 42-50-degree latitudes without the added boost of the currents, that this distance is navigated nearly 20,000 miles further than the official distance of 25,000 miles of the Vendee Globe Race, and nearly double the distance of the Earth's alleged equator circumference. It's quite interesting that the one globe race that does not use GPS technology and does not follow GPS, meridian distance corrected waypoints, but only uses physical waypoints, navigates nearly 20,000 miles further than the globe races that use GPS and GPS waypoints with distance corrections, but I'm sure that's just a big coincidence. We can also take the latitude and longitude coordinates from the Vendee Globe Race route map and plot them on a flat azimuthal equidistant map. This route would look something like this. You can see they are still starting at France, heading down to Cape Town, Africa, then to Cape Llewellyn, Australia, then over to Cape Horn, South America, and finally back up to France to finish the race. They would be following along the interior circumference of Antarctica rather than outside of it. And again, they would be following the many different pre-coordinated GPS boundary waypoints throughout the planned route of this trip. These GPS boundary waypoints have built in GPS meridian distance corrections, so the speed and distance they are navigating will not be accurate, as the meridian distance correction affects their GPS reported speed traveled between the waypoints, which then alters the overall distance traveled on the circumnavigation. This is all planned by design and pre-coordinated into the GPS infrastructure to hide the true distances below the equator, while also hiding the true nature and vast length of the Antarctica coastline.
This is the ocean currents according to the flat Earth map and also according to the globe. Calculating the speed of these ocean currents not easy. The main current in the Southern Ocean is the Antarctic Circumpolar Current, ACC. The ACC is the biggest current in the world and can transport up to 150 billion liters per second of water and reach speeds in narrow channels of up to 1 meter per second. But how do we calculate the speed of the currents? In this National Ocean Service webpage, says that to measure currents, you need 3 basic tools: an observer, a floating object or a drifter, and a timing device. An observer stands on a ship, throws the drifter into the water, and then measures the time that it takes that object to move along the side of a ship. As technology improved over time, oceanographers began using mechanical current meters. A ship would deploy a meter, and usually some sort of rotor would turn and measure the currents. This is still the basic process today. However, there are more accurate and sophisticated instruments. This current around the Antarctica is the biggest and the fastest one, as this professor explains.
So I've mentioned several times that the Southern Ocean is special because it has no zonal boundaries. It's a complete channel. Since the Southern Ocean is a channel, winds can keep on churning it. So the main features here are the Antarctic Circumpolar Current, one of the more famous currents. It's also known as the West Wind Drift, and it's the only current to completely go around the Earth because of the special channel configuration of this ocean. And And this obviously moves more water in terms of sphere rips, the transport, than any other current in the world, right? So look at this figure carefully. It is showing multiple convergences and divergences here. So you have the Antarctic circumpolar current outside, or the west wind drift.
As a matter of fact, in this National Geographic website, they call the ocean currents as ocean conveyor belt. They are similar to the jet streams. Once you are flying with the jet stream or sailing along this oceanic conveyor belt, you have no friction because you are moving forward with the current and not against it. So to better explain, let's imagine a person standing on a conveyor belt, walking conveyor belt, found in airports all over the world. So as you observe this person, he is just standing on the conveyor belt, and in 28 seconds, let's see how many people will go by in front of the screen if the person only stands on the conveyor belt. On example number 2, we will see this person walking, and you can see how much faster he moves from left to right. And in this example, we're going to see a person going the opposite side. As you can see, he remains on the same spot, no matter how hard he tries to go against the flow. So that's why they always organize this race going from west to east, because they will go with the flow. They're going to go with the ocean currents, especially this Antarctic current, which is one of the biggest and fastest one, and that's the way they will be going from west to east.
This is we're going to be talking about boats here real quick, because planes, I think, can get up faster than we think. And also, I showed articles on my show the other day. There's already been articles that such and such plane has broke the sound barrier, because with the winds aloft, and that's just in the north, when the south is many times faster. But in the north, planes will catch that stream and they'll get places a lot faster, and they'll break records. And then there ends up that their miles per hour was 950 or 970. But that's because they were going under the Mach and then Mach 1, and then they get the wind with them. So, but boats cannot really, as far as I know, aren't going to move a lot faster than we think, right? Like a cruise ship that goes 22 miles per hour is not going to bust out and do 40. It's just, I don't think it's possible. So when you look at boats, let's start with this Antarctic Cup Race, right? Which is what people always send me to. This is the cup race that they have once a year. They show the path of the races here. So basically, they will race around this track. They don't go below the 60-degree marker. They race around this, and then there's a world record. And the current world record you'll see here is 102 days, 56 minutes, 50 seconds. Okay? So remember that they sail the entire time. They don't take naps. They don't, as far as like somebody will sleep, somebody will sail, but not. They're always moving. So at 102 days, we'll do a 102 times. Let me get this up. We'll keep track here. So 102 times 24 hours equals 2448. That's the amount of hours that this thing was traveling. And it did a circumference of 16,000. Where does it say the miles? I think it's 16,000 miles. I don't see right up here. It's a nonstop race around 14,000 nautical miles. I don't see it right. It should be about 16,000. Let's just say it's 16,000 and we'll come back. But 2448, so that's the hours. So we're going to go 16,000 divided by 2448, and we get 6.53 miles per hour. Okay, so that's how fast he was averaging to get around 16,000 miles in 2,448 hours. Okay, great. Now let's look at what the circumpolar current is. Okay, it's the biggest current in the world. It is the fastest moving current. Here you go. The Antarctic circumpolar current flows clockwise, okay, which is the way the race goes, which is the way people circumnavigate the world. You have a hard time doing it the other way. And when I say circumnavigate, I mean on the outside track, obviously. And it talks about it goes west to east around Antarctica. Anyway, when you look into it deeper, you can figure out that the average speed is about 2.5 miles per hour, sometimes 3. So we can now take that 6.53 miles per hour that we said the guy was averaging, and we can minus from that 2.5 because that's the current speed. So he's moving without even moving 2.5 miles per hour. Therefore, his boat is only actually going 4 miles per hour around the world. Okay, so now we find out who this guy is, and he races let's find his name here, I think. He races his 85-foot open monohull trading boat. So I go search and find the fastest 85-foot monohull, and you find out that the boat goes 36 knots. That's 41 miles per hour. Wow. So a boat that goes 41 miles per hour has the world record for circumnavigating the ocean while traveling 4 miles per hour. Okay, so if you believe that, that's fine. But that's what happens when you're lying to people about distance. The guy probably got back, and if you asked him, for all he knows, he was going 4 miles per hour because he traveled 16,000 miles and it took him X amount of time. That's what speed is, right?
He probably just divided the math, and he divided the time into the distance and said, right. Wow, I thought I was going a lot faster than that, but it only says 4 miles per hour.
Right. I'd love to talk because I bet you would say something like that. Uh-huh. So, and then all of a sudden you realize there's not a lot of difference you have to do. So if instead we know that there's 2,448, well, let's say some people have said that the circumference is 60,000. I don't know. I don't know if things are that big down there, maybe 50,000, but let's just say 50,000. Just to see what speed would somebody have to go to complete that. And he's not all the way at the edge, remember? So the edge would be 50,000. He's not even past the 60 degree. He's just doing a circle at about the 60 degree mark. So let's say it's 50,000.
Yeah, they're usually in like the mid 50s.
Yeah, so
or thereabouts.
We'll go one more time and look at where was the boat? Here we go. So you'll see that they're not even getting, this is the 60 degree line here, this white line. And so they're staying above that. So right below Australia, they do have to duck down, obviously, in South America. Anyway, so it's not even the outer edge. So let's say it's 50,000. So we've got 50,000 divided by the 2,448, and that comes out to 20. So even at that, the boat's only going half the speed that it's capable of. That seems to make more sense to me than a boat that maxes out at 40, breaking a world record going 4. It's just ridiculous. It's like a car breaking the world record for the fastest trip around a track, and it actually goes 400 miles per hour, but it only went 4. What are you talking about? Why would it do that? Wouldn't somebody just come and break the record easily by going 8 miles per hour? Same thing is true with these boats. Doubt. Why isn't somebody breaking the 102-day record by going and, I don't know, putting your foot on the gas pedal at the boat? You might move a little faster than 4 miles per hour. And so that just tells me that this area here is much more vast, and nobody would ever know. It would be impossible for a sailor to know because they're going to base everything off of known land distances, and those, when I say known, it's what GPS gives you. GPS gives you these answers. So when you figure out that, that boat fastest goes 41 miles per hour, and yet this guy's breaking the record going 4, it's that to me is a big problem. And then the other thing with
the Antarctic sailboat race, which they have every couple of years, they don't even
actually have that written down.
Yeah, they don't go near Antarctica. They can't even see Antarctica. They're like 50 degrees south, 40 degrees south at some points. And even on their website, the last time they did it, there's one leg of the race from Africa around Antarctica and then over to South America. That leg, which is a big leg, was 32,000 miles, according to the race. Wait a minute. The equator is just 25,000 miles. How did just going around that little 13,000 mile continent turn out to be 32,000 miles? And then they had another 10,000 miles to go to finish the race. How are they going around Antarctica and making a circle bigger than the equator? Weird? Can I get a weird?
Yeah.
Can you explain that one in a different way? I wasn't able to follow that.
So if you look at Antarctica on a globe, It's a continent at the bottom of the globe. It's kind of a circular continent, and they tell us it's about 10 to 13,000 miles in circumference. So if you wanted to sail around it, you would go about 13,000 miles.
Okay.
So the Antarctic sailboat race, you've seen those sailboats. They're the most high-tech sailboats in the world. They're amazing, right? These are the fastest sailboats in the world. And they're saying that the one leg of the race, which is like 2/3 of the race, was 32,000 miles. You got to remember the equator, which is the biggest circle you can put on a globe, is only 24,900 miles. So how did that one leg become 32,000 miles? The other thing is, when you're out in the ocean, you don't know how far you're going, because if you're not over land, you don't know how far you're going. The only way to be told your distance is GPS, pretty much, right? And GPS is run by NASA. And so when they look at it, they say, okay, the trip took us 30 days or whatever it was. I forget it was 30 days, 60 days, whatever the amount of time it was. And they say, okay, well, at 50 degrees south, the race should have been like 18,000 miles or 20,000 miles, whatever it was. So they take the time divided by the distance, and they say, well, the average speed was 3 to 4 miles per hour. 3 to 4 miles per hour. Now, are those boats those boats can go 3 to 4,000 miles an hour when they're tied up at the dock, right? 3 to 4. The reason it's coming out like that is because they're traveling a much bigger distance than they're being told. And so we had at least one of those sailboat captains has come on our shows saying, I know how they're faking it. The earth is flat. We're sailing much greater distances. They're using magnetic declination to hide the flat earth, because there is no magnetic declination on the flat earth. It's only on the globe that you have magnetic declination. Good. Sorry. I'm talking a lot, so you guys ask.
No, totally fine. And that was going to be my next question is, are these people that are taking part in this race, are they being lied to, or are they lying?
No,
that was my big question.
They're not even being lied to. They're being lied to by GPS, the ground positioning system. But some of them are figuring out. Other people are like, oh, well, I guess it was a big current. I guess, these guys the boats are going 20, 30 miles an hour at times. But the average speed is 3 to 4 miles per hour if you take the time and the distance that they've traveled.
The distance.
Yeah.
Okay.
And, and it's hard for them to figure it out, because they're like, well, we're at 60 degrees south. Now we're at 40 degrees south, and we're here. These guys, when they're done, they're sailors. Okay. They're not there doing math. They're there, sailing as fast as they can. And I don't know why they all don't speak out when they hear that they only were going 3 or 4 miles per hour. They should all know. But it's willful ignorance, if they don't. But a couple of them have spoken out. And
as Hervé has discussed in prior videos, as part of the cabal's process to change our flat Earth reality into a false globe, the controllers artificially enlarged the northern hemisphere and simultaneously shrunk the southern hemisphere. In other words, actual distances in the east-west direction in the northern hemisphere are shorter than claimed by maps and the globe, while in the southern hemisphere, actual distances between points are farther away. But the same does not apply in the north-south direction. This deception has created various telltale signs of manipulation. Due to his experience in sailing, Hervé noticed that actual distances were shorter in the northern hemisphere and farther in the southern hemisphere. In addition, both false magnetic declination adjustments and time zones certainly hide these changes. In my opinion, the time zone deception is the most obvious, since there are only 19 time zones in the northern hemisphere, while there are 31 to 32 time zones in the southern hemisphere. That only makes sense on the flat Earth. In his last presentation, Hervé also showed us how road map scales in the north are wrong. Road maps have been artificially stretched to hide the fact that driving distances don't match the distances of nautical mile straight pathways of airplanes and boats. To be clear, your driving distance aren't wrong. Driving distances cannot be altered, but nautical mile pathways of airplanes and boats can be altered. But the controllers had to make it appear as though the driving distances match the nautical mile distances of the straight pathways of airplanes and boats. For example, an airplane that supposedly flies at 520 knots may actually only be flying at 260 knots. I'll have links in the description to Hervé's prior discussions on these topics if you haven't seen them. This next presentation builds on the roadmap presentation by showing how boat speeds based on nautical miles are artificially inflated. It's very difficult for a sailor to determine independently how fast he's actually traveling, and that's how the controllers have gotten away with this. For the first part of the presentation, Hervé shows how the official recordings of the American Cup competition were artificially sped up to make it appear as though the boats were traveling faster than they actually were. Officially, those boats supposedly travel up to 80 kilometers per hour or 50 miles per hour, but the actual speed is much less. You'll see how the movements of the sailors appear much more natural when slowed down by approximately 30%, and that when the official video is compared to independent footage from a spectator, you can see the speeds of the boats have been artificially increased. For the second part of the video, Hervé goes into detail about the apparent wind angle used in sailing. Officially, those American Cup boats are supposedly traveling at 80 kilometers per hour. He demonstrates that those speeds are physically impossible for sailing. This part may seem confusing, but when his car was parked, the true wind angle came from behind the car and to the right at 135 degrees, as indicated by the weather vane. But as he began accelerating, the apparent wind angle shifts to the front of the car. A sailor would be aiming for an apparent wind angle of 27 degrees to inflate the sails, and that angle becomes impossible as the car travels faster than 45 kilometers per hour. A sailboat cannot travel faster than approximately 45 kilometers per hour because the forward apparent wind angle makes it impossible to inflate the sails. Very interesting. Based on the evidence Hervé has uncovered, we can see the methods of the controllers have used to create the phony sphere, which confirms our flat Earth reality. Anyways, let's get to
here. This is the world record holder for sailing from San Francisco to Tokyo. It looks like it's only been attempted twice. Original record set in 1969 took 39 days. Okay. That record stood until 1992 when Peter Hogg broke it in 34 days, which is still the record to beat. Now, it should not take 34 days. Now, this is supposed to be, I think it said 5,400 miles is the route they take. They went a little bit south. It says the shortest distance, the Great Circle Route, is 4,500 miles, but that would take me north. And so he went down, passing close to Hawaii, at 5,700 miles is what he's saying. So for 5,700 miles, you divide that by 34 days. That's 167 miles a day. You divide that by 24 hours. You're getting 7 miles an hour is all he's able to do in this boat. Now, the ones they race today, they're very similar to this, that they're setting these records with. He would have to be doing better than 7 miles an hour. This is the new world record for sailing around the world in 42 days. He was averaging 31 miles an hour and did over 27,800 nautical miles. Okay? 27,000 nautical miles is 32,059 statute miles or land miles. So if he did 32,000 miles in, let's say, 43 days, 32,000 divided by 43 days, he's averaging 744 miles a day. Could that be right? It would have to be, right? 744 miles a day. You divide that by 24 hours. Yep, you come up with an average speed of 31 miles an hour, which it says right here. He reportedly averaged 31 miles an hour. Okay, so if you could average 31 miles an hour for, let's say 5,400 miles, 5,400 divided by, let's just say 30 miles an hour, 180 hours, right? Divided by 24. You should be able to make that in 7.5 days, if I'm doing this right. Yeah. 7.5 days, he should be able to make it from California to Japan, which would shatter the current record of 34 days. Okay, and you can also look up some of these cruise lines. Now, if you look at this, ports.com, and try to map out a route from San Francisco to Japan, it shows you going this way. 19,000 miles. You know, I think there's now if you look at this, where it says you can pick a sea route, go from California to Hawaii up to Tokyo, it says it'd take you 11.5 days at 20 knots. Okay, so this record should be so easy to shatter, but why is nobody doing it? No team, all the circumnavigation, if they start here, they all go this way. Now they have to go around South America and around Africa and around here and come back up. None of them go this direction. None of them go this way. There's a reason for that, I believe. Like I said, you can look up cruises. Here's a cruise from Los Angeles to Tokyo. 60-day cruises. $7,400. They all go up this way for some reason. And then when they come back, they come across here, but 60 days. And you tell me they couldn't make it quicker than that? I mean, you can look up these cruises. They do not offer a short cruise from California to Japan. I mean, this is all out here online. This is just another nail in the coffin. So if the flat Earth map is correct, everything has to go past Alaska from California to Japan. Okay, normally they probably fly out here around the circle, so nobody will get suspicious, whatever. But all the emergency landings go to Alaska. All cruises go through Alaska from LA to Japan. And just another proof right here. And if anybody can find any other people that have sailed these routes, but there's a reason they hadn't done this since 1992. Back then, and then it says, nobody followed him. He had no kind of equipment tracking him. It says, there is no longer an organized trans-Pacific race to Japan. So I set up my own record attempt with an official timekeeper designated by the World Sailing Speed Council that certifies world records on the Golden Gate Bridge to take the starting time, and another timekeeper at the finish line in Japan. So nobody was watching him. No teams have ever done this that I can find. The only people who have ever done it have done it solo. And they haven't been tracked. So I don't think this route exists. They should be able to do that way faster. It should not take 34 days. But if you take his 34 days and say he averaged 20 knots, you can read a thing on here. They say a cruise ship can average 20 knots. This would have to average 20 knots at least. Okay, 20 knots would be 23 miles an hour. So if you go 23 miles an hour times 24 hours, you get 552 miles per day times 34 days. You've traveled 18,000 miles. All right, this is just another huge nail in the coffin. There's, these people that do these records, they live to break these records. Why would nobody have tried this yet? Now, here's a world race where they start here in France or somewhere. They go out and they go this way. They always go this way. I said any race you see, if they leave from California, they come down, they go around this way. And guess what? This is from NASA. All this information about these races is coming from NASA. Wow, this is huge. I mean, I don't know if anybody else has looked into this, but it's all right here. I mean, what, you don't think this guy would love to just shatter a record from California to Japan? I think if they tried it now and they had people following them, they know that it would take way, way longer than it's supposed to, and that would tip everybody off. That's why they don't do it. Let me know what you think about this, but and if anybody's got any other kind of information, that'd be great. But, you know, these Trans-Pacific yacht races, they're racing from L.A. to Hawaii. Now, why wouldn't they just keep going on past Hawaii and try to make it to Japan? I mean, they're going, you know, from California to Hawaii in 5 days. And that's 2,500 miles, so that's about half the distance that it's supposed to be to Japan. So, I mean, they could shatter that world record easily. Why don't they do it? Just another question that I don't think they can answer. I think this is the reason. There's no way they can. I mean, Hawaii's out here, I'm guessing. There's no, but Japan would be much, much, much further on a flat map. All right, like I said, y'all look into this, research it. You know, if you could actually make this route, you should be able to do it in 11 and a half days. Not even racing, doing it 20 knots. Go to, I said, a cruise ship cruises at 20 knots. How big a cruise ship is? It's supposed to be able to do that in 11 and a half days. They can't do it in a racing boat. I mean, I'm sure it's a sailboat, but you know, some of those sailboats can average 90 miles an hour. They should be able to smoke it across there. All right, that's all I got for this one.
Now we are going to talk about the circumnavigation of Antarctica by Lisa Blair in 2022. This was an unassisted, non-stop circumnavigation around the continent of Antarctica between the 45 to 55 degree latitudes. When you search for this circumnavigation, usually the first images that you are going to see are something like this. They show the trip starting off in Australia and then going around Antarctica and traveling along the two other capes and then back to the tip of Australia. Now, just for reference, this is not the actual GPS navigated route shown from the Mercator Map Projection GPS navigated route on the Vendee GPS app that was used, but rather a rendered drawing extrapolated from the Vendee GPS app of what her GPS coordinates would look like plotted on a globe map. Let's take a closer look at the GPS log from the Vendee GPS that was used to track the trip. Once we view the tracker, we can open the GPS log and get a better idea of her GPS coordinates. This is going to show the longitude and latitude coordinates, the speed, the heading, and the distance traveled. Now, for reference, she is also following GPS safety boundary waypoints, just like what is used in the Vendee Globe Race. So keep in mind that these distances and speeds are not entirely accurate, as they are calculated with GPS meridian distance corrections between the GPS safety boundary waypoints, which will affect both the distance and speed reported, and I will get into more detail on these distance corrections later. From here, I was able to take the GPS coordinates and plot them onto a azimuthal equidistant flat map, and the route looks something like this. As you can see, the circumnavigation route she was taking navigated around the interior circumference of Antarctica and not around the outside of Antarctica. This circumnavigation route took 92 days to complete, with a total distance of 18,507 miles, but you will see how the numbers for the circumnavigation do not add up and greatly contradict the numbers of the Golden Globe Race when we hypothetically add the last leg of the Golden Globe Race into Lisa Blair's circumnavigation. Let's look at the math for this circumnavigation to get a better idea of the distance that was navigated. This circumnavigation took 92 days to complete and took about 18,507 miles. The boat used was a Hick 50 monohull yacht with an average cruising speed of 8.9 knots per hour or 10.34 miles per hour. If we take this 10 miles per hour times 24 hours, we get 248 miles, and then the 248 miles times 92 days, we get 22,830 miles. And if we figure this with the adjusted Antarctica circumpolar current speeds, we get 14 miles per hour times 24 hours is 344 miles per day. Then we can times that by 92 days for a total of 31,662 miles, which again is many more miles than the 18,507 miles that was claimed that she navigated. Now, if we look at the Lisa Blair circumnavigation and we compare that to the Golden Globe Race and add the additional leg to France because she did not sail this leg on her circumnavigation and essentially sailed half of the Golden Globe Race. So, if we look at the estimated mileage of that leg up to France from Cape Horn and then returning back down to 45 degrees south latitude on Google Earth, it comes out to approximately 15,752 miles. If we then add the 18,504 miles from her trip to this leg, we get a total of 34,256 miles. If we then figure the number of days to navigate this distance based on the 2022 trip cruising speed of 8 miles per hour, this hypothetical Golden Globe Race route would now be completed in only 170 days, not the 260 days the Golden Globe Race claims. This is nearly 100 days less to navigate the same route with similar yachts with nearly equivalent cruising speeds. Even if we factor in the difference of 1 mile per hour between the two different cruising speeds, this would still only take an additional 28 extra days if Lisa Blair was to navigate at the same cruising speed as the Rustler 36 yacht, a total of just 198 days, again not the 260 days the Golden Globe Race claims. The vast mileage disparities between the circumnavigations that use GPS distance corrections and the globe races that don't use GPS only becomes more apparent. Now let's get into some more information on the GPS meridian distance corrections that have been cited in GPS papers dating back to the 1990s. Many of these papers were analyzed by GPS experts and analytics at that time, only to find many different issues that the GPS was not accounting for, and having to make corrections in order for the GPS to function on a globular coordinate system. At this time, from the correspondence between different letters, documents, and papers. These corrections were never directly addressed, ignored by academia multiple times, and have since been swept under the rug and not addressed. Among some of the many of these corrections were corrections for Sagnac effect, relativity simultaneity, and latitude meridian distance corrections. One particular paper written was the GPS, and the constant velocity of light published by Newton Physics.
GPS synchronization has been verified in numerous experiments. It is identical to the calculations presented in this paper and also to the Sagnac effect, which is included in the GPS. Among the list of the corrections, there is a correction involving a parameter taking into account how many Earth meridians are crossed by the path of light or by a moving clock move between the what?
Wait, what?
What?
Are
Yo. Yo.
clock.
Whoa. Whoa. Red flag.
Meridian again?
Red flag. So the latitude line. So every every time it crosses the lines. Like
it says
right
there is
here.
a correction involving a parameter taking into account how many Earth's meridians.
So anytime it crosses one of these lines, Toby.
There's another account for it, right? Another parameter that they add into it.
Dude.
Go
Dude, Toby, we're never going to be able to get the distance using GPS, dog.
No, of course not, dude.
No, look at this.
Not.
Literally to the fucking meridian, bro.
Among the GPS list of corrections, there is a correction involving a parameter. There is a correction involving a parameter taking into account how many Earth meridians are crossed by light. Dude, wait, so GPS signals are based on by numerous experiments and identical to the calculations. Where can we pull that? I would like to pull that other one up at some point. Maybe I can pull it up on my own.
The clock synchronization thing?
I want to see that, but we're never going to see that. They're not going to show
the clock synchronization. Oh my god. Dude. No, we have to go look right now. Because if that's in there, what was that document called? I highlighted it in green.
You got it marked in green, yeah.
Yeah, it's
oh wait, no.
Down here.
I think it was towards the top. I thought.
There it is.
No, not that one. That's close though.
There it is.
This one right here. Yep.
Yep.
We're gonna go pull this up.
Like if we can find that will be pretty cool.
Dude, correcting to the meridian, bro. Get the F out of here. You could never, ever say anything about, we use reciprocal GPS angles. Sorry, buddy.
You're missing the point. If we lived on a plane and then somebody projected it onto a sphere, there would be latitude and longitude for every location on the plane Earth on the sphere.
That's literally how we created
That's how
the
they
way
do
that
it.
we created latitude. Was we took angle measurements to Polaris down to the ground. We took elevation angle measurements to Polaris. So we have a ground position directly under Polaris. Like if you were to get to the North Pole, which by the way, you can't go there, then Polaris would be at your zenith, right? That's a ground position. And then what we did was we took angle measurements with our horizontal baseline going out to the ground position and then going up to Polaris and then an angle to that. And what we did was bring that angle down to the ground, and we kept on making these measurements further and further away from Polaris, and we created the latitude system with concentric circles around the North Pole. Then we took that and we put it onto a globe. Then we took the globe and then we put that into a cylinder, and then we flattened the cylinder out, and that's where we get the Mercator map. So the actual origin of the latitude system is a flat Earth set of measurements. It's transformed into a globe. The difference is going to be when you get really far south. The longitude is going to begin to compress down on a globe, converge back down, right? But on the flat Earth, it's not going to do that. So to really test the difference, you're going to have to get far enough out south, which conveniently you also can't do that. So longitude and latitude work on a flat Earth. They're actually created from a flat Earth. Latitude's created from a flat Earth. And actually GPS and satellites and all this, they make meridian corrections in the south. They make meridian corrections to even get the right location and distance for the GPS satellites, which shows you that the globe doesn't work in the south.
Well, and think about this. You said that it's down to the minute or down to the second that you said sunrise and sunset, but we just got done telling you that refraction means that the sun's not actually there. So it isn't mathematical. It can't be, or else you're going to be off by a half a degree every day. It has to be. The sun's not actually
changes every.
Yeah, because they're all shown this. They're all shown the relativistic framework. Once they have that lens of interpretation, any varying speed of light, they can just start invoking different "quote unquote" relativistic effects. And so, back to real quick on the satellite coordinate system transformation. So the initial, sorry. So the original coordinate system that they that everything is derives accurate distance under, when they transfer out of that, that's when you can get into things like hiding distances or adding, spherical excess and stuff like that, because they're in a completely different coordinate system. They just need to make it match like in local areas, right? So like in a city, like there would be a different coordinate system for that. It would be more it would be more accurate. And then if you were traveling over a long distance, highway span or whatever, they could adjust distances like that. And you would think, you're traveling X amount of distance between this city. And then when it matches locally to the thing, you assume the whole thing is, but you don't realize that it's literally doing constant calculations of coordinate. It's just coordinate system transformations that are all based off of an original preferred directional speed. Thank you for the time. I appreciate it.
I wanted to talk a quick minute about GPS. And sorry for my scribbles, but hopefully this will help you understand a little better. If the map on the left was the correct map, and we needed people to think that they are on a globe, then you would put ground-based tracking everywhere. So let's call that those red sticks on the map on the left. Then when someone stands, say, at the 3 dots in South America, then it would coincide with our GPS, or global positioning system, which would be the 3 dots on the right. We could just say that those 3 dots were being tracked by big metal satellites orbiting above your head, when in actuality they were ground-based stations. Now, if someone thinks that they are going from, say, South America to Antarctica, on the right, they would actually be just doing the same thing as we see on the left. Same thing with Australia. Going from Australia to the South Pole would look the same way on the left as on the right. And as people fly around the world, the GPS simply tells them where they're going. So even though you're just doing a big circle, the GPS makes you think you're on a globe. So,
against to get that amplitude to the fringe. I think the biggest thing is that it absolutely does. And the GPS satellites being, or the GPS code being closed source. And every time I say that, I see people in the chat saying, it's not closed source. Here's a link, here's a link, here's a link. No, I'm not saying that it's not a code that you can implement in your device. It is, but the transformations, the numbers, the mathematics is not for you to see. Yeah. So if you lived on a plane and you needed to return to somebody where they would be on the globe, what you would do is you would have those mathematics embedded in your balloons or whatever you're using, so that when a signal is sent from there and you are saying, here I am on the Earth, they say, here you are on the globe. And that's it. Bro, I did a presentation on that recently. That's exactly how it would work. So when I said, I mentioned earlier, like a shadow coordinate system, that's exactly how it would work. It would all be relative to the center of the ECI. So you would take like the center of the North Pole, right? You would have everything out from there. You would have its accurate position and everything in real space relative to the actual map of everything. And then you would have that projected onto a globe, right? And the difference in there would all be encoded in, and you would just do scale invariance. So when people see a satellite move across the sky at whatever speed they say, they're like, oh yeah, it's proportional to it going across the speed at that distance, but the altitude could be vastly different. But the signal that they send is it's encoded with the information that the satellite is coming from 22 kilometers out, right? So it's already backwards compatible with it on the back end. And in addition to that, you would already have it work that way, and not even necessarily for nefarious purposes, for military reasons, right? Because you wouldn't want to have somebody, of course, be able to actually derive the altitude of your satellite so they could attack or something like that, right? Its actual position. So you would have it, that would already be built into it. And then on top of that, I don't know if you noticed, Jaron, but they have what's called meridian corrections built into the signal time. So it deduces like how long the time was taken, and it applies a meridian correction. So it's basically like how long the speed of light would, if it propagated for X amount of time, how many meridians would it have crossed, and they adjust the time of that, thereby or thus adjusting the distance. So like you can't even use GPS to get an accurate reading over long distances, because it's always going to go back to the globe, but it's going to be super accurate short distances. But that's how they're going to hide it. Correct. True. When you try and check over long distances, it's going to be globular. Yeah, these guys are like, show me a plane that's going 1,200 miles per hour. I can't, because you believe in the GPS distances. Dude, yeah, it gets super hard with that, because it's already corrected and baked in. Like I was reading this paper from the 90s where these gentlemen wanted to go and look at GPS corrections to verify the speed of light is the same in all directions. So when they did their analysis from the raw GPS data from the main central place in Colorado where they store all the data, the data that they got was already SAGNet corrected, doing air quotes. I'm sorry, my green screen is blocking it out, but it was already quote unquote SAGNet corrected, and they say that this is due to the rotation of the Earth and whatnot. It doesn't make any sense. Not to get into the full specifics of that, that's absolutely not the case. And what they're actually doing in that data is applying first order velocity corrections to the speed of light to make it seem like on the GPS end that the speed of light is the same and it's deriving the distance based off of that constancy. That's not true. They already corrected it on the back end before anyone even gets to see it. So the idea that like you can just go to an open source, I'm going to go to GitHub and debunk the globe. Yeah, Jesus. Yeah, miss me with that. You know what I'm saying? No, and then that guy that we had the interview with, Austin and I were talking to him, and he's like, yeah, but it works. It works. It's like, yeah, it works. That's the deception. Like, you shouldn't be surprised if we're saying, hey, you're being deceived. And then you're like, yeah, but it works. Yeah, we know that. That's why it's a deception. If it didn't work, we wouldn't be having this conversation. Nobody would ever have believed it.